Hi, hello and welcome to BK'sTechStack. I am BK. Today, we embark on an exciting journey into the realm of data science with Python. This course will equip you with the fundamental understanding of how data can be transformed into actionable insights, driving innovation and informed decisions across various industries. Get ready to explore the fascinating intersection of data and artificial intelligence.
Data analytics is far more than just crunching numbers. It's a synergistic blend of diverse disciplines. At its core, it's a systematic process to extract meaningful insights from raw data. Crucially, effective data analytics begins with deep domain knowledge. You can have all the technical prowess in the world, but without understanding the business problem or the context of the data, your analysis will fall short. This is augmented by strong statistical skills, which allow us to rigorously test hypotheses and validate our findings. And of course, the backbone of modern data analytics is programming, typically in languages like Python, which enables us to automate data processing, build complex models, and implement advanced algorithms rooted in mathematics. Ultimately, the goal of this powerful combination is to facilitate robust, data-driven decision-making.
The data analytics process is a structured journey, typically comprising 7 key steps, often iterative in practice. It all kicks off with clearly defining the business problem. What question are we trying to answer? What challenge are we trying to solve? Once we understand the problem, we move to data acquisition, collecting all relevant data from various sources. This raw data is rarely pristine, leading us to the critical phase of data wrangling, where we clean, transform, and prepare the data for analysis. Following this, we engage in exploratory data analysis, or EDA, a detective-like phase to uncover initial patterns, anomalies, and insights. Data exploration is often intertwined with EDA, where we delve deeper, possibly evaluating initial models. These insights then lead to formulating conclusions or building predictive models. Finally, and perhaps most importantly, is communication, effectively presenting our findings and recommendations to stakeholders in a clear, understandable manner.
Data acquisition is the critical second step in our analytics process, focusing on collecting all the necessary raw material. The primary goal here is to gather data from various sources that are pertinent to the business problem we've defined. This requires a unique set of skills from the data scientist. You need to be adept at handling different file types, from simple CSVs and Excel sheets to more complex JSON and XML structures. Furthermore, understanding how different data formats are structured and often leveraging web scraping techniques to extract data from publicly available web pages is essential. The sources of data are incredibly diverse, ranging from streaming data from social media platforms via their APIs to internal enterprise system server logs that reveal application performance, and of course the ubiquitous relational and NoSQL databases that store vast amounts of structured and unstructured information. This phase is all about casting a wide net to ensure we have a comprehensive dataset to work with.
Exploratory data analysis, or EDA, is arguably the most crucial phase for understanding your data before formal modeling. It's where we become data detectives, studying the dataset to summarize its main characteristics, uncover hidden patterns, spot anomalies, and even suggest which models might be best suited for our problem. A key aspect of EDA is its focus on the data's inherent structure, identifying outliers that could skew our analysis, and generating preliminary insights without making grand assumptions. It aims to reveal the data as it truly is. We employ 2 main categories of techniques, quantitative and graphical. Quantitative methods help us understand the numerical properties of the data, such as measures of central tendency like the mean, median, which is particularly useful for identifying outliers, and mode. We also look at measures of spread, like variance, standard deviation, and the interquartile range to understand data dispersion. Graphically, we use tools like histograms to visualize the distribution of a single variable, showing its center, spread, and any skewness. Scatter plots are indispensable for examining relationships between 2 variables, helping us quickly identify if they're linearly or nonlinearly related, and if there are any glaring outliers or dependencies. Mastering data analytics requires a comprehensive toolkit of both skills and tools, tailored to each stage of the process.
Starting with the business problem, it demands sharp questioning abilities, deep domain knowledge, and a robust analytical mindset. As we move to data acquisition, specialized tools like Beauty Soup and Python for web scraping become invaluable, alongside proficiency in handling various file formats and interacting with databases. Data wrangling, which is often the most time-consuming phase, relies heavily on Python libraries such as NumPy for numerical operations, Pandas for data manipulation, and strong database interaction skills. For data exploration, NumPy and Pandas continue to be crucial, complemented by SciPy for scientific computing and Matplotlib for foundational plotting. When we arrive at conclusions and predictions, scikit-learn emerges as the leading Python library for machine learning, alongside the continued use of numerical and statistical libraries. Finally, for effective communication and visualization, Matplotlib is key for creating impactful graphs, and familiarity with presentation tools like PowerPoint is essential for conveying insights to stakeholders. This comprehensive skill set truly makes a data professional indispensable.
Thank you for watching. I hope this deep dive into data analytics has provided you with a clearer understanding of its processes, challenges, and the essential skills required. If you found this content valuable, please take a moment to like this video, share it with your network, and subscribe to BK'sTechStack for more in-depth explorations into the world of technology and data science. Your support helps us create more content like this. See you in the next one.